Outstanding Technical Achievement Award this year goes to Professor Chang Wen. I think everybody knows him. And then he was many conference keynote speakers. I don't know how many times I attended his keynote speech. I think he's very well known in the community and even his students. So, his students. I think he has made a great contribution to multimedia computing and communication and application. So it's my honor to announce this year Outstanding Technical Achievement Award, Professor Chang Wen. Thank you. And the award certificate I will give during the dinner. So, but he will give the keynote speech for Technical Achievement Award today. Thank you, Chang Wen.
Thank you. Well, I think I like first of all thank the Peggy to introduce me to the stage, and I indeed give a lot of the keynotes, but this one is different. This one you would talk about the other things. This time I turn to myself. So I spent all time looking back. So I really kind of interesting that I have a very interesting academic family. So, but let me see which one is which one. I think this is the one. Okay, so I think let me. I'll be very happy here, and I'd like to thank everyone for coming to this special edition of Keynote. I think you might have heard of my keynote before. Usually I just joking around in the first few minutes. But today, I think the first one I'd like to have an acknowledgement. Because this talk is dedicated to first of all, is who guided me through this initially. And then, of course, along the way, there are many people, especially my students, and many of them actually, several of them is on site. And you will see their name when I talk about those groundbreaking research. Many of them actually, you will see different persons because some of them actually did different things when they do PhD, and then they develop into different areas. And of course, this is the first batch, and I have many mentors, even though I'm actually old, but there are older people than me, some of them in the audience. And walking through my professional career may help me a lot. And I know many of you have been helped by me too. And I think those senior people, I couldn't pay back. My way of returning their help is going to be helping younger generations. So my mentors and my collaborators, like many of them are in the audience too. We are working on a project, co-author paper and so on. But I think today is special, so I have this very sincere thanks to Professor Prof. Who actually my nominator, and he insists on that, for those people he knew that, who already get award, and probably the next in line, actually, sometimes we have private talks that, oh, you deserving more than some of them who are getting more, but that's his personal opinion. But also to this nomination supporting team, Clara, Shifu, Zheng and Yang. Okay, so those people are supporting Rafa's effort putting this one together. Of course, I also, of course, like to thank the committee. You see the committee members for their selection, and in that case, that without their selection, I won't be standing here today anyway. Okay. Of course, I think that my special thanks goes to my wife, Angela, who is down there, and also our children, Kang and Joanna. Okay, so I think if I can focus on my research, it's because of their support throughout my career and so for many years, and they are also inspiration for me to carry on because of their love. Okay, so with this, I think I'll turn to my next one, which I'll talk about today's outline. Okay. And essentially, is I have a very interesting career path. And also many of you know me in different fields, because if I go to communication network, you say, oh, Professor Chen, you are in our community. Yes, I am in that community. And we come going to multimedia, and they say I am in multimedia. And also, interestingly, 2017, the Hawaii CVPR, I went there after 25 years. My last before that was 1992 CVPR. But so many people say, good to see you again. They say, when did you see me last time in CVPR? Probably last year. I say, no, that was 25 years ago. So with this, I wanted to also echo my career path actually just like visual computing. For many years, we started some algorithm mental systems. Okay, of course, in particular, I have the following. One is I actually done interesting work during late 80s and early 90s until probably end. So in that case, this is mainly algorithm. I have not touched anything on the system and yet. But in the next 10 years, I do a lot of things in addition to algorithms and also systems. And of course, after that, it's going to be the more system and algorithm for the next 10 years. And then now, as you can see that, we actually now moving into multimodal. And I'll talk about what my experiences in this area. So that's about it. Both are according to the timeline and also according to the kind of evolution from algorithm system. Okay. So with this, of course, everybody knows me. Why do you select this area? Of course, this is back to my college days. I was majoring automatic control, and there are many equations to write, and even though we get a result, it's all equations, and there's no intuitive. So one day I find my friends doing image processing. They say, "Wow, this is really good because you can see the result right away if the code went through, right?" So this is the kind of image, even though we don't use this image anymore, but I think this is actually, initially we use this everywhere. And there are stories, when I teach image processing, I can talk about story, but today we don't need to because everybody knows the story already. Okay, that's how I invited into this field. Of course, later on, I do much more in-depth research and then look at this is what I have. And our brain is actually particularly tailored for visual. Okay, and even though it sounds like everybody has a great capability, but we actually don't know all the way yet. Still have many of perception problems we have to solve. In the middle, I'll talk about this semantic gap. This is part of it because our brain is performing much better than whatever the model we talked about today. Okay, so with this, I will probably talk just 2 minutes talking about how we evolve from the algorithm to the and for today, we see this everywhere. We have visual sensors, and that's why everybody know I asked a question on the first keynote. Okay, then this all kind of visual sensor we have to deal with, and that's also motivated me to work more towards design because we still have many puzzles we need to solve. Okay. With this, let me also look at the conventional way of doing that. Is essentially is just algorithm. Okay, so you have input here, your output. This is algorithm. Okay, and usually it's a single performance measure. Okay, we can do good, but if we're going into multiple ones, then it's a different story. But with this evolution from the past 10 years or 20 years or even more, we actually see this. We used to do it in the lab, but now we can get all this data, and we have to touch every block of those if we really wanted to get something done. Of course, we don't just end there getting the data. We also need other way around to share the data or maybe to broader audience. But in this case here, I used to just take a picture from a lab and then doing, analysis and so on. But now it's going to the field. And the analytics is from software to embedded the processing to the front end, so on and so forth. I'm not going to go through all this. Then, of course, it's no longer just this single routing direction. We have the next one here is all coupled. meaning that many of the tasks we carry out, we need to know cross-layer. And I have a few examples here, but I'm not going through that. Systems considerations instead of individual performance measure is going to be the concern. And that actually dating back to my own undergraduate education on our control system and feedback. I heard the most beautiful sentence when I attended this control conference in June. And the people in the control community, don't tell me you are doing AI. No feedback, no intelligence. That sounds right? So those people in control, they talk about feedback. And actually, all these learnings that we have to go through, we have to do certain type of feedback. Okay. So with this, there are many measures we have to work with, and I'll talk some of them during my time. So let me just begin with my initial years. And I think some of the senior people here will probably know me. Okay. So I did it this one. And this is under the occasion that, when I joined Tom Huang's group, and he told me, can you come on a certain day? I said, yes, I'll be there before, one day before. Next morning, I walked into his office, and he told me, this is about 20 to 30 papers you can read. And I'll be in Europe for sabbatical for 6 months. We'll see you in 6 months. That's my first day of my graduate PhD study. What do you think? Okay, so 6 months back, I hand him already technical report at that time, and he told me, this is your sister topic. I said, what? This is just what I did on the casual way of doing this. But anyway, so this actually is doing the stereo matching, and I want to do an error analysis of those matching. Okay, so you can all see here. So one of the things that I introduced in the computer vision community they never thought of before is introduce what we call error probability. Okay, so we have that, and we have all the formulations and so on and so forth. This is I call groundbreaking in a certain sense. In that case, it's a numerous computer vision problem that can be formulated as a system of polynomial equations, okay, based on physics first principles. And then the solution to this equation is actually a distribution. It's no longer because the data we are providing, they are random variables. Okay, so that's how we got this error probability. Because Tom told me, hey, you're the first one in computer vision to talk about this. We always use this geometry in that case, because when we do this stereo matching, you try to find out the depth. The depth actually is not single point, it's a region. And people are using geometry to do that. I'm not going to talk about that. What I'm going to talk about is, this is my first paper, okay? And this paper is, I think it's 89 or 1990s, okay? So this is actually coming out of my 6 months of the self-working without Tom Huang. He was in Europe, I think, spending time with the university over there. Okay, so the implication of this here is the following. Okay, you probably you don't realize that polynomial equation is the simplest one of all different kind of equations, because you know the number of solutions. Okay, so but it's not trivial in the sense that this total number of Q here is actually factorial of Qi. Qi is each of those equations. There are how many of them? Typically, this is number of variables, and then the order of the variables. As polynomials still have like the Q, and so on and so forth. So essentially, this Q is probably in computer vision problem between 80 to 200. And in order to get to work, because of randomness of the solution, you have to get all solutions and to see which ones fit in the physical. Of course, many of them you don't even consider because mathematically they are just, or physically they are not possible. Mathematically is the solution. So this is the underlying implication of this error probability-based analysis is when the coefficient of such equation are obtained from practical measurements. Of course, they are random variables, and then all the solutions of the variables. Okay, so that's why Tom tell me, this is great. You should do this because when they solve this problem here, then you're not famous in computer vision, famous in all engineering disciplines. Wow, that was kind of shocking, right? And I was studying PhD student. We never thought of that. But anyway, the story goes like this. This one actually is we did it. We did some theoretical analysis later on, and then we found out that we cannot verify. In the late 80s, we don't have a supercomputer to be able to verify the polynomial equation up to I think at that time about 80 or 100. Anything more than 100, we cannot do it. So I think they can say, Chang, I have another problem for you. Okay, it's frameworks called non-linear motion and estimation. Okay, and of course, if you don't know Tom, then actually he was the person during that time is doing rigid motion. He's so well known on this area. And even that time, I think he has his paper during the 1980s, in early 80s, have a few thousand of citations. Of course, it's easier to do today. Think about it in the 80s, okay? So he is the one who has done rigid motion, and they say, Chang Wen, you're the one who should do this non-rigid because I think you're from the USTC, you have good math by showing your error probability things. So this is the one you do. And this is the new grant I got. Okay, so we got to do that. Okay, so this is actually crucial actually to start with. If this is non-rigid, we should have some constraints. So the one he selected is going to be hot. Hot is closure. And we can get, we do have that kind of data available. It's called DSR that time. It's called Mayo Clinics. And it's going to give you 16 volumes of three-dimensional CT image of the heart. And within one heartbeat. So about 1 second. Okay. So I work on it and try to do that. That was the one, of course. So I did it, but one of the things is on the heart we have 4 chambers, but left ventricle is one of the critical ones. So we'll focus on that left ventricle motion and why I think that this is a good or this is also because in the existing motion model it was doing global motion deformation, mainly characterized by overall changes, or you have other things like the ECG and so on and so forth. The existing deformation model focuses on local things, local structures, and the computation model has been mostly heuristic. So what I do, of course, I have good math, so I say maybe you should do mathematical model. Okay. So this is what I have. I have this hierarchical shape and motion model. Okay. And the global shape and motion is characterized by what we call superquadrics. Okay. Is ellipsoid, deformable ellipsoid, and all kinds of things. Because I tell you that the heart is not just contracting expanding. At the same time, they also do twisting. Okay, I'll show you a little bit later on with some more picture here. So this one is essentially the spherical harmonic is introduced to characterize what if we compensate for global. Whatever left is going to be local motion, local shape. And the reason introduced is that the spherical harmonic is 2 things. One thing is, of course, is enclosure surface. The other thing is what? Heart motion is a periodic. So harmonic makes sense. Spherical also makes sense. Okay. And of course, you think this is not easy to do mathematically. I can tell you, I have read hundreds of papers on the biology of the heart during my years. Okay. So I guess it's interesting you can do this and eventually we get something going, okay? So, and of course, one famous, I told my students and others, I say, Tom and I will work for 1 semester without being able to formulate real problem, okay? So, interestingly, I have concern at the end of the semester, I said, Professor Wang, we don't know even how to formulate a problem yet. And his advice was, don't worry, Chang Wen, when you are able to formulate a problem, you will have the solution already. So don't spend less time on formulating problem. Spend time on formulating problem, the solution will come right after that. So people are rushing right now. Oh, we get this guy and things like that. I think it's the best advice I get from Tom is try very hard, correctly or reasonably, with all the support from mathematics and physics, correctly formulate a problem. Okay, so this is the on the penny, and of course, interesting is I get a fast track on this because the editing tube that had a Neogen, and Tom told him that I still get great work in this language, the first one in this area, and Neogen say let's push it quick. So I think from my submission to that time, my submission to eventual publication 2 years. Okay. So it's, that was quick. And this is one of the things I want to show you. This is actually the motion we estimated on this, and you can see this. You know, they can't at the same time they are twisted. Okay. So I just wanted to show that complicated models and interestingly. So of course, this being noticed by many people, and including one from UCLA. And he was doing very different things. I'm doing quick ones, right? 1 second with 16 morning. He was studying adolescents' brain morphology throughout the years, maybe 10 or 15 years. And he found this very interesting and it worked. And he said, oh, this guy is true mathematics. I'll just call his name. So I have a Chen surface. Named after my work at my PhD. Okay, so I think that's and of course there are more actually beyond that. Okay, therefore for the natural language object, okay, you really wanted to do it just like you have to study many biology course. Get the real physics, the first principle behind this, and then you can work better. And of course, this Lagrangian shape, can be applied to different things. And if you are doing just we did it, okay, Lagrangian shape motion, you put it Google, I'll find out that there are more than 10,000 papers, and guess what? My paper is on top. So that's how we get to that. Okay, and of course we also use it for none and so on and so forth. So that's the one. I did it for my PhD. Actually, my PhD proposal had 2 parts. One part is of mathematical model, and the other part is physics. It's called continuum mechanics. And I have this proposal, and Tom said, "This is great." Okay. And then after I finished the mathematical modeling, Tom said, "You can graduate." I said, "What?" "Oh yeah." I said, "What happened to the other part? You asked your student to do it." So I did. Okay, but anyway. That's a story. Let me switch gear a little bit. Then, of course, I graduated and I first joined after that. But I think many of you don't know that this particular areas actually is also built another person's outstanding career. Okay, so this one is actually called different field. Okay, so we are actually characterizing this spatial relation of the image with this very rigorous mathematical theory, okay? And then of course, can do a lot of things using the same principle because I'm pretty sure you know that if you do image processing will tell you 4 neighbor, 8 neighbor. They are very heuristic. This one is very rigorous, okay? You can do all kinds of things here. So with these different applications, and I have outstanding at PhD student at that time, and he did it all, okay? So this is the paper. We received this bachelor paper work by Jill, okay, with somewhere, I think down there. Okay, so this is his first paper, I think, 1994. And later on, he told me, Chang Wen, this is great because I changed his career. And I think that's probably true because during that time, there's no other image processing company, only have this. IC came later that year, and or whatever else I think is not there yet. Okay, so that's Jacob. Okay, so I think that you know what's going on. So that's the basic 1994 Bachelor Award. Okay, but this actually have much more implication. Okay, we have lasting impact. I'll show you that this paper was submitted in 1994. Before I think Jacob graduated, Jacob finished his PhD in 3 years. I think that was a record at the department. I'm not sure there were most smarter people later on, probably not, right? So we have this, and we send it to, and I'll tell you the kind of joke. Actually, we sent it to, after 2 years, I contacted the editor. And editor very honest with me, Chang Wen, I forgot to say now. Because that time he had sent the hard copy in and out. And I told Jimbo was concerned. Then what happened? I said, don't worry. Because he didn't do his job. So our paper had a better chance to get accepted. You see that logic? Okay. But anyway, so that paper was being silent for probably about 10 years. Of course, we have occasionally the citation here and there. And look at this year. So from probably 2010 to right now, we still have probably 20 to 30. This, how many years after that? It's actually 30 years after the submission, about 26 years after the publish. Okay, so I think people that, and I ran into one person who cited this paper, I think in 2021, and they said, why? I said, Professor Chen, we wanted to do this more rigorously, and guess what? We checked, and you've done it many years ago. So that's interesting. That's, I think the people is some credit here. And in fact, you probably don't know, he was doing all this image coding. His PhD thesis is the image coding. So I think last year sometime I asked him, do you know the last chapter you wrote for your thesis? No, I forgot. Because I do so much for computer vision. I said, last chapter you wrote was video coding for wireless. That was 1995. Okay, so we have vision. If we don't have the vision, you guys don't have the smartphone right now. Enjoy your video. Okay. So the next one period time is starting from about 2000, and this is the one that we, although it's not directly related to Jimbo, but we have another outstanding student of mine. Okay, so this is actually Jones Hall channel coding for wireless video. You see here, I'm from computer vision right now, become more networking people. And I was actually, I have been known in that community say, they all think I'm doing networking only. And on multimedia, they all think I'm doing multimedia only. Because I never left the visual part. So even at wireless, I have visual part here. Okay. So with this is, we have discovered this wireless impact on this encoded MPEG-4 video. Okay. And of course, the MPEG-4 can do using predict coding. One of the things here, with predict coding, compressed data here is very sensitive to error. Okay, so one unique way is that if for wireless you have fading, that means you have consecutive errors. What's going on? So I think I'll tell you, I'll give this, I'll mention his name a little bit. I give to my PhD student and say, you look at this, and we have expectation that if the fading is too bad, the result should be bad. And he told me, oh, get it done in a couple months. And then I'll report you result next week. And then another next week. And then another 2 weeks. And another 2 months. I say, what happened? I check all my code. The result is counter to our expectation. I said, no problem, just sit down, we'll analyze that. But anyway, so we actually eventually discovered this guy. Okay. But anyway, so let me have his name here right now. So that's what Jim Fei's work. Many years ago, I'm not sure he's still remembered by you. Okay. So his work is first research discovered that there are actually this interesting relationship if you are compressed video and you are running into the wireless. Okay. So Jimbo is a wireless guy in the wireless community. So of course here he is everything, right? Okay, so we have this unequal error protection have to be done, and we also have this joint source channel coding because in order to come back to channel error, we have to do channel coding too. And channel coding we have to use unequal error because the bit after compression is very different. Okay, okay, that's Jim Fei. Okay, so we have this one on this. And of course, then we also have working on the joint source channel coding here. And this is another my collaborator who actually discovered that the linear relationship between the percentage of zero and also the bit rate. Because we have to do joint source channel coding, we have to adjust the rate. We have to make it adaptive. This linear relation gives us great advantage. Okay, So that's the one. And then of course, if you know the channel status, can you predict whatever the quality you receive? That's the one. Okay. We show that if we start from the very beginning, we know the channel, then we can do a good job. Even though we don't know the channel, after a while we estimate, then still track after that. Okay, if you see this, so this is actually a very the high impact paper on this area. Okay, so this is actually also being done by many of these current wireless companies because if you want to send a video, they have to do something like this. But anyway, the principle, I did not file a patent, so I have no way to get any money out of it. Jeffrey also didn't get anything. Okay? So how this? This is the paper I was talking about. Also, we have Jeffrey and Zihai, both are the authors of this paper. Okay, so this is one area, also working in between 2040 and 2010. The third area I'm working on is for compressive sensing for larger scale sensor network. See, I was in network community, they all think I'm doing networking, but if you think about it, it's actually, I do a lot of this visual data networking. Okay. But in this case, it actually is not quite visual data, but they have a problem. Problem in the sense that you have a lot of massive network. You have to compress those sensor data. After compression, usually is whatever you try to find is missing because when you do compression conventional way, then the unlikely events will be filtered out because those are high frequency. Okay. So what we have here is we are able to do. If you see this, the blue line and the original, and of course other people's work, we show that we are almost can recover everything, especially those heights. These are the abnormal meter or data. Okay. So we did this, and this actually was my first mobile account paper. And if anything about a communication area or networking area, this is the toughest conference. Okay, every year I have 30 papers. It doesn't matter how many submissions. I think I heard recently that increased to 60. But anyway, so this is the one I see for very, we'll talk about another, we have several mobile account papers later on, one of these more recently, okay. So this is actually essentially the impact of this is the following, okay. This is actually counterintuitive because when we do compression, usually you take off all the peaks. Okay, you remain trained. That's the low frequency of remain. But we are actually doing this. The result we do is counterintuitive here, and we can preserve this abnormal sensor signals to pick up which of the sensor is bad. Okay. And that has been used in Microsoft Data Center, I think since about 2012, okay? Because those are the kind of way. This is compressive sensing. I don't have time to experiment compressive sensing as well like that, okay? So with this, now we are moving into 2010s, and now it's time, we are actually more focusing on system now. It used to be more algorithm. Our second part of my talk, we have certain system aspect, but this part of research is mainly on systems. Okay, so what we have here is the first one we have we call socialized mobile photography for smartphones, and I think many of you can probably as a witness to see how early this one was probably I think 2013 or 2014. People are doing that right now. Okay. But anyway, so we have this, we have popularity of smartphone, then we are taking pictures, but most people are not well trained, so how can you take the best picture possible? If you are putting into certain tourist spot, say, okay? So we have here, we actually invented this photography model to assist mobile users capturing high quality photos. And of course, we're using rich content, we are available to them. We also make use of the social media, which Jay was talking this morning, but we use it a different way. Okay? And of course, the photography model is learned from the community contributed image on the web. So they have those wonderful pictures. You just follow those examples. But on the spot, okay? And of course, we also use other information like the location, time, and so on and so forth. So this is the one is actually interesting. You do composition, you do other things. So the pipeline goes like this. You have people there. I've been to there. Say for example, this one is located in the San Francisco Golden Gate Bridge. Okay. Of course, you can probably take any picture of the Atlanta Gate Bridge. You are not taking the best possible. So we're making use of our own algorithm and systems. You can do that much better. Okay, so I just wanted to skip that. And this actually the paper is really is I think I will heard later on say, Professor Chen, you did it 10 years ago. Yeah, almost 10 years ago. So this is actually my student is Wen Ying, who is in Google right now. And also, we also have collaboration with Chang Wen. I'm not sure he's here. So we actually have. I think Chang Wen like my student very much because they saw all future interns. You have to like Wen because what? Because he gets a paperwork during his intern time. Okay. So that's another. This one is that's very. So I told Chang Wen. You know how long we haven't been there? Because last time was JPOS 1994. This is the 2012. Say, I have to wait another many years. My student won't get it until a few years later, right? According to this cycle. Okay, so this is course supervisor. I just wanted you to acknowledge. Okay, so then the second thing we wanted to do is also, I think this one still being quiet, but I myself think it's very useful. It's called doing rate distortion energy profile. Yeah, I think many of you heard about rate distortion. But when you apply the rate distortion to your mobile phone, what is most concerned? Battery. Right? So the behavior of video stream, if they have embedded the energy profile there, you do much better. Okay, so that's what we have. Okay, so mobile video, the power consumption, and historically, this is the one that we extended to that. And then most time is we are aiming at the QoE instead of other QoS. People are talking about QoS, but service that's not equivalent to your experience. Okay, so QoE certainly is the one that power consumption is really concerned because when you watch a video and you still halfway run, it tell you that you need to recharge because the extra power is fine, but if not, it won't happen, right? So this is one of the things here. And rate distortion display energy profile. And it goes something like this. Let me just tell you one of the things we make use is dash. Okay, it's called dynamic interface streaming over HTTP. Okay, so that's why I'm feel comfortable with the networking community. And this is the one you have. This is the regular classical rate distortion. And we have multiple curves here. One of the curve is, that you can do save data by voltage scaling. This hardware. So my student is no hardware too. So that's how I get into system. Okay. And of course, if we this profile here, they are significantly enhance this possible way of. If you say you desire want to have 10% saving, this is the curve. If you want more than that, this is the curve, or down a little bit, and so on and so forth, right? But if you just do in simple ways, just do voltage scanning, they save you energy, they save you power, but the quality is lousy. Okay, so that's how. Okay, so this is the another vector world. Actually, I can tell you very interestingly is in this location. Is the ACM 2012 is held in Melbourne. Okay, so we got this the very interesting location. So this is actually what we have, and of course, eventually we publish that conference into this transaction on cloud computing. Okay. Okay, so that's the winner of the ICME 2012 Best Paper Award. Okay. You can count how many Best Paper Awards, but I don't list them all because I need to lap out something for you to guess. Okay, but anyway. Okay, so that's the second area working on the 2010s. Okay, the third area is of course this is actually a human-centric mobile video computing system. Now it's really building systems. Okay, So we have here is, we have all this related to human vision theory, smartphone visual system, but they don't get connected because only unless your phone has something to understand your visual system, then you don't get the best out of it. Okay? So what we have here is we have multiple ways of doing this thing. One of this, currently I think most people have OLED, the screen, and we can do editor reduction on that. We can also do brightness scaling, dynamic video quality display. We also do rate the brightness. Means that you can send in such a rate, but you might be with not very good brightness. Okay, so we can do that too. So with this, I'll talk a little bit. So in fact, current iPhones, you have too many pixels already. Okay, so we have to solve that problem. It's by my student. It's in the Multimedia 17, and we also have another paper doing this. The crowd source, the brightness scaling, and this is actually shown on that. And this is actually another MobileCom paper. Okay, and you can see that MobileCom requirement is when you sign a paper, your system should be ready. Okay, so we have to work out a system. But this guy actually doesn't get any conference best paper award, but he got what? He got SIGMM, the award for outstanding PhD thesis 2018. Okay, so with that, I'm going to the last part of my talk. And I think still fine, right? I'm doing fine. Okay, so I think I talked too fast. I think I can tell story. I can't tell story. I think I should share with you all this first. Okay, so the second, the last part is from about 2020 on. Because look beyond what is conventional visual computing, and also now we are moving into more adult AI systems. And you can see how I do things in this area, and we need a little bit more background in this case here. So let me talk about first one thing is this is called Internet of Video Things. You might not heard of that, but in China this is very popular, and major companies are all using this. I did it first keynote at China Multimedia in 2018. And I didn't prepare that well because I was driving to they invited another overseas speakers, and the last minute, the person could not come. And I think the conference chair called me, can you help me out? Okay, I know you are, I think at that time was in Shenzhen. Okay, you travel here easily, but you still have your hat with the international experience. So I did it, and I talked about it. I said, I have a vision that the current IoT won't be able to sustain in a few years to come. Many of the sensors will become visual sensors. What do you do? Change everything. Everything from the sensing end, there's such a massive one, because many of those front-end IoT are no longer doing periodic sampling of the data. They do continuous sampling. For example, all these cameras on the street, okay, they will look at it all the time, but although they don't pick up these events, they will probably keep silent. But you never know, something will go back. So the sensing part change, and then when we have such a massive data, networking becomes another problem, because historically, Internet of Things, actually they're assuming that you have what we call no duty cycle, okay, meaning that I work 1 minute, I sleep for another 5, and then we can again, sometimes sleep for another 30 minutes. Because, for example, monitoring temperature, you don't need it to do that every minute, okay? Maybe every 30 minutes is good, okay? So, and then of course, at the end, we have to send this massive data and all this to the cloud, okay? So I envision that this is a called triology of sensing, networking, and integration, okay? And certainly, this is very true multimedia system. It's no longer just the algorithm, okay? So this is one of the things I did. And of course, this is my first author paper. When I was a student, I co-authored with Tom. When I become a faculty member, I co-authored with my student. This is the first time IoT edited issue called me,
say, Chang Wen, I heard you did a great job in the Keynote. This is a brand new idea, and I'm the IoT General Editor-in-Chief. This is actually the kind of thing we want to do in the future. So he asked me to write a paper. He said, you know, it's easy. I spend one day, maybe plus an evening, I can finish all the PowerPoint. But converting that into a paper is not easy job. But anyway, so he was so insistent once I did it, I spent my next 6 months on and off, and I wrote a paper. So this is my first single author paper. So I don't know how many of you can write a single author paper, but anyway. And then also interestingly, there are another editor-in-chief. It's called Discovery IoT. Also, I know him personally. He said, Chang Wen, it's not fair. You wrote a paper for him. You did not write a paper for me. You had to do it. He said, what can I say? He said, oh, I have already said it in that paper. So think about something. So I said, oh, maybe if we change that regular sensor to Zoom, then it will make it much more challenging. So I wrote a few challenge points in this case. So this is the second paper I didn't want to show here. So one of the things here is essentially the front end is Zoom. Okay, Zoom has many limitations, but they also have a built-in thing. So they're actually connecting all the continuously while flying over this target. Okay, and that actually require much more stringent networking things than the one. Okay, so dynamic operational mode for data acquisition, information transmission, and knowledge extraction all the way. Okay, so become a loop here. That's interesting. Okay, so that's all I have to say about this IoT. You can actually go. I think it's crazy right now. A lot of people have even in the paper title and put the IoT there. So I think this is one of the areas. Then this is actually probably last point here. 45 minutes, still 15 minutes. I can tell stories, right? Just what? Okay. You told me 45 minutes, right? I started at 1:30. Okay. But anyway, I can go quickly. But I think that this is really important. It's called semantic communication. Sharon is the guy I actually admire most among all. I don't care about whatever Turing or Windows, whatever. Sharon is the one. It's only until recently because he talked about this communication 3 levels here. I'll just go quickly. Okay, give me maybe a couple more minutes. So I have this technical problem, first level, and then semantic problem, and effective problem. In fact, for all the years we spent, for 1G to 5G, we only worked on the first problem. Now there's 16 that talk about semantic problem, okay? And of course, I'm going to skip this because everything is we have done so far is based on this paper, mathematical theory. But in 1953, here we will point out this new level of things. Okay, what we have here is the currently. Let me show you why the other day I asked the question. Okay, so standard current communication paradigm. Okay, for that, I already talked about. I want to show this. You can have it, find it for current, I think available in 2022. 80% of all IP traffic, visual data. So I'm not afraid of doing that. I told my students, don't worry about a large language model. Language and vision, they are different. Language has many constraints you have to follow. Vision is very free. Very free means also it's free for you to do research. Okay? So this is the one, and then this is actually in the sense that the data is going crazy. At the same time, the percentage is growing. So we don't have anything to worry. Well, one of the things I wanted to do is that maybe we can help communicating people by using visual computing principles. So that's what I do. And this is one of the key persons in China doing this 6G. So he was invented for semantic communication, or that is called SAB. Okay, this is SAB is a semantic base, unlike the one we have 0 to 1. They have their basic things. And then when I asked him what basic you're talking about, he showed me this. Show me the which one is going back? Okay. Show me this. Oh, there. Oops. Okay. Oh, we have different shapes of the world. Yes, we know that. We have millions or maybe billions of objects. They're different shapes. But that doesn't solve all the problem here. I told them we have problem because he put a comparison here. Bit sequence for the conventional communication, SAT sequence for this. And then my question is, how many unique objects can you house in such a space? Because then I say, if you really want to identify the object, you have to do localization. Like the one we have in the binary case, we have 0 and 1, that's all. A different length of 0 1 combination represents some data, something, all right? In this case, we don't, okay? So with that, I tell them that localization is necessary in language and also in visual data here. What is localization? In the language, of course, we have words, subwords, characters, okay, so on. They're well defined. What happened to the vision? Well, we don't have such things. We have tried before. Of course, we know that localization is attempted, but obviously pixel voxel doesn't have any semantic meaning, right? Even though we try to have super pixels or patches, that doesn't also give us anything. We still have this gap. My kind of vision is if we can do good vision and language integration, we probably can solve some of the problems here. And I have examples to show that at least for certain applications we are successful doing this. Okay, so with this, I'm not going to tell you what the semantic description is. I wanted to really show you the semantic gap. So semantic gap referring to a disparity between low-level data and high-level understanding. Wow, we still don't have high-level understanding. Is any of you say we are closing the semantic gap division of challenging you? Okay, we have a debate. Okay, so actually we don't. Okay, so how do we do? Okay. The new paradigm is for communicating people, they're dealing with voice all the time. For large natural language processing, they do language all the time. They all think everything can be language. And I just tell you that you check out that in April of Nature, they have MIT group saying that language does not mean intelligence. Okay. So I think I encourage you to do that. Then of course we have all this massive multimedia data, multimodal data. What can we do? Can we do? Of course, the things I wanted to do is look at the different types of communication we have: human to human, machine to machine, or human to machine. Okay. So I'll have an example in the next year is when we do human to human, we want to hear stories. I think a lot of people are like to talk to it because I can tell a story. Okay. And the stories, of course, you have emotions, you have imaginations, and of course you can your own subjective things. Okay. Of course, we wanted to machine to do this. This doesn't work. Why? Machine doesn't understand much of emotion, even though some people can. But I think it's not going to be good if we translate information to a different remote area and then you put your own emotion in. Machine should be able to do structured graph. Okay, this is actually scene graph generation for machine to machine here. So that's how I have seen here is, but this single scene graph generation has a problem because we rely on certain data and labeling. You know how many objects they have? In the thousands. Okay, so they can do, because what they do here, they have to label the object and the relationship between them, which is not very easy. Plus, all the labelers are lazy because they only give you a simplest the relationship. For example, somebody holding a cup, they will say not holding the cup, the cup is next to the person. What do you mean by next? Okay, so holding is the key. So we have all this problem here is giving them anything that not in a database, they will just want to work. So we have this for open vocabulary scene graph generation. We have this right now, and we can do what new object we can do, and by going through visual language integration, and we can do new relationship, or we can do both relationship and object because we have done that, and we think we kind of under certain conditions we solve the problem. Okay, and this is actually the fresh of paper of the ECCV. This is actually, if you can see this expanding scene graph boundary is fully open vocabulary. And guess what? This is earlier this month. We get this ECCV best paper candidate. So I think we're recognized by the community that this actually is the way to go. Okay. So with this, I think I'm making good time, right? Because Freebie asked me to allow some time for questions. So my summary goes like this. My career is actually mirrors evolution of the visual computing. I started with algorithm in the nebulous system, and I can tell you it's much more fun to do system. But I can tell you that your citation will go down. Because when you build a system, only survey paper will mention you, nobody else. because all you've done it. So who cares? It's better to have an algorithm. In that case, that you also need some backdoor so that people can improve. Every time they improve, your paper will be cited. But don't be proud of that. Just kidding. Okay, you can do whatever. But I think that people at my age will probably are much more relaxed, less pressure to publish. Okay, so the second thing is, I had to learn a lot. We're coming from single performance measure to holistic ones with balance. Okay, this is actually not so fun to work with, and this is also the reality. Because how many of you can claim that many of the algorithms are actually in use? Probably publish CVPR or even more prestigious one, but how many of you can have? We have several to show you. Okay, interesting. And of course, the multimedia type. I have been working with growing from single visual modality, which actually generate in the lab. We have camera and we generate. We put some cones there, and we will say we recognize the cone. That was in the 80s, right? Now we have this multimodal AI generated data. We have voice. Okay, so in the future, I actually looking forward to working with this very vibrant, super friendly community, and then we'll hope everybody can work together to take a SIGMM to the next level. Okay, with that, thank you.
Thank you, Professor Chen, for an excellent talk. Any question for Professor Chen? Any question? Yeah, please. Thank you.
Professor, first congratulations. I think your research, starting from the time is small to being independent actually supervisor, you change quite a lot. I think the big difference is that you consider system, but for system, seems like collaboration between industry with the lab is very important. To give, for example, give some advice, for example, for our young researchers, how to have a very good relationship with industry and they achieve the next level of excellence.
Very good question. I've just been talking about as if I'm actually older. I did mention earlier that throughout my career, especially my early career days, there are lots of people helping me out. And of course, and also interesting that you mentioned that for starting career for the professionals, especially in the academia, of course also in the industry too. How do you build up your initial stage? I think one of the things here, I'm very lucky that I work with Chang Wen. Okay, so I think in those years, Chang Wen student is known to be independent immediately after the graduation, and the reason for that is essentially his supervising style. He will leave it to you. He is such a great. When I was his student, he already like the top in the world, right? And our initial months, I'm very cautious when I discussing with him, and many times we have some idea and then try to approach. And he's very appreciative of that and say, this is the way, the better way. You always better than me. Go ahead with this. So this kind of encouragement, I think, if you are in the PhD or you are still in the early years, is very good in the sense that I think a lot of people actually, you are smarter, you are better than you think of yourself. Just be confident. Regarding this selecting area, I'm pretty sure that we have to change the numbers. Of course, I'm not changing numbers, we're all changing numbers. But I think there are ways of doing good things at the same time to still get the number. Not intentionally giving back or those are not, I was joking. But I think in many cases here, even my PhD students, they are probably struggling initially
But I insist on that for a PhD student, if you are graduate from a group that insist on you doing your own open research or original research, I think you'll be much better off when you walk into academia or industry because you're already been trained that way. If your advisor, some advisor, do that, insist on his way, and I have so open with Tom, so I think I was kind of used to that. I thought every advisor was just like Tom, close enough, right? So after I become advisor myself, of course, I know that it's not easy, especially some of you professors, you have ego. I also have ego, but let it go and be open to your student because they will benefit much more. By selecting certain areas, I think it doesn't have to be you follow other people's framework. Because even though you maybe get cited, but actually people don't remember who you are. They only remember the framework, the first one of the, and of course you sometimes you have to be. I will say that you have to wait until the time to imply. Like I have one example here. Actually, I have multiple examples. I just show one that here. In the first 10 years, nobody noticed that work. Suddenly, if you're really doing this type of work, they will be noticed sooner or later. But I'm pretty sure some of our works in the 2010s, they notice now and they say, "Oh, you've done it before." I say, "Yes, you've done it." So like socialized photography, mobile photography. Prof, I think it's being seriously considered by current many of this iPhone, Huawei or whatever if they want to do, because that's the kind of things to help users have a best possible core experience. I don't think for anybody you have fixed career paths. Okay, everybody has your own individual ones. But as long as you are open-minded, I'm pretty sure sooner or later you're going to succeed.
Okay, thank you very much. Yeah.
Okay.
Yeah, congratulations to Chang Wen. So I think you did great job to mentor so many great talents and so many great students.
No, it's the student who themselves actually are excellent. I'm just lucky to get them. And I think if any advisor will turn their student from like middle level to the top level, that will be successful. The advisor. I don't think I get all the great students, but somehow after they graduate from my group, they become great. The entering is different.
So we still have many young researchers or young professors in this area in the multimedia community. So what if you give some advices to those young generation? For example, some of them are still struggling on research, on their career, on their mentoring, teaching services. Yeah,
I think answering the Suzanne's question, I talked a little bit about that. Thank you. And also I mentioned Chang Wen and myself, actually, we work on different papers, different interns. Somehow, if I have a problem with my student, I'll send it to Chang Wen and he will make work. Okay. But I think that's good. So regarding this advice to the younger generation, I think one of the things here, I think first thing you should aim high. Okay, don't just satisfy with whatever little things you do. Okay, but at the same time, you also have to be really working on it. And I think research is interesting that it takes time. Okay, and if you have the short-term goals, sometimes in conflict with your long-term goals, you should select the long-term goals. Okay, but I know a lot of people have the career pressure in terms of the years to tenure and so on and so forth. But I think one of the things here I'd like to give this younger generation is if you believe in yourself, you're doing great things, you should be fine. It doesn't matter if this is the case, you probably will be successful if not in certain environment, not some environment, not all environment fitting everyone. you find the one you probably be changing your and getting to that location or institution that will appreciate your unique talent. Okay, and just happen to be in my case, I've been to different universities. They're all working good for me, and also I have mentors, collaborators help me all the way. I think the mentoring is a very complicated work, and sometimes it's actually sometimes you have just for the advisors, you have to cool down sometimes your students. They are very anxious, and for the case I just mentioned for this ECCV best paper candidate, the student came to my group with a good experience, and he told me, Professor, I have just read a few CV papers. I can do 2 of them, and I promise I'll do next year. I said, well, you don't want to do that because you want to have your own. So that's something built his own, and is happen to be appreciated by the community immediately. Some of my students probably take time to do that. It's time now.
Yes, thank you. I'm sorry, I don't have to interrupt because otherwise we can't finish it. The award section. Thank you for being here.